Okay, so I've already indicated the strategy for merge sort, but here we go again. With recursive thinking, it's a simple idea. Take an array, chop it in half, use recursion on each half, and then somehow merge these two sorted halves together. Okay, well, now that's the part that we haven't discussed yet. We believe that recursion will allow us to produce two sorted halves, but we still have the problem of how to merge them, push them together in such a way that they are that the resulting entire array is sorted. Okay? And that's going to require the auxiliary array. And it's going to require scanning each of the two sorted halves from left to right and comparing elements of the two halves as we go. If we scan each of the sorted halves from left to right, we'll begin by comparing the smallest element in each of these two subarrays, right? Because they're already sorted. Whichever of the two elements we compare is the smaller, well, that, of course, has to be the smallest element of the entire array. And so we want to take it and copy it into the auxiliary array, into the position 0, into the left end of the auxiliary array, right? The idea is going to be to end up with the original array copied into the auxiliary array, but in such a manner that the auxiliary array is sorted. And once we have that, once we have the entire thing sorted in the auxiliary array, then we can do just a straight copy back to the original array. Okay? Here's the code to do it. Comment, let's read the comments so we know what the strategy is. It says, let's see, uses recursive merge sort to sort an array P. Again, it's kind of funny to use the letter P for an array, but there it is. From position left will be the index for the leftmost position of the leftmost portion that we're currently sorting, and right will be the rightmost position. Okay? Let me pause and clear here. Of course, we're interested in sorting the entire array, but we're going to have to make recursive calls to this function merge sort. And those subsequent recursive calls will not be responsible for sorting the entire array. They'll only be responsible for sorting a subarray, a portion of the original array. So we'll need to specify the left and right indices for that subarray. Okay? Yeah, that subarray will then get split into half, or split into two further subarrays that are nearly as equal as possible. Okay? Then recursive calls are made. Those two subarrays will be recursively sorted using merge sort, as we've already discussed. And upon returning from the recursive calls, the two sorted halves will be merged together in a manner that we began to describe on the previous slide. We'll look into it in detail here. Okay? Q will be the auxiliary array that we've discussed. Okay, so here's the guts of the code. Well, this is the code. First of all, let's look at the header. The original array that we want to sort is P. That's the first parameter. The auxiliary array, Q, is the second parameter. Then we have two integer parameters, left and right. And you have to be very careful here if you're not accustomed to it. It says left equals 0. Well, that's a default value. If you're not used to it, this is not, in all cases at least, this would not be setting left to 0. It's only going to set left equal to 0 if left is not passed as a parameter. What I'm saying here is when this function Mergesort is called, it can either be called using 4 parameters or just 2 parameters. If it's called using 4 parameters, then a value will be passed for left and a value will be passed for right. Okay? But if it's called using only 2 parameters, p and q, then the left will be set equal to, the integer left will be set equal to 0 by default, and the integer right will be set equal to n minus 1 by default. So the fact is, it's only the first call to Mergesort that you want to pass just 2 parameters, p and q, because on that occasion you're trying to say, I want to assert the entire array. Okay? Subsequent recursive calls will involve 4 parameters. All right. And now there are a couple local variables, integers, all of them, I, j, k, and middle. Okay? The body of the function is basically this conditional statement right here. If left is less than right, then do a whole bunch of stuff. Okay? It's only in the case when left is less than right that we need to do anything at all here. Okay? If they were the opposite, if left was bigger than right, then we'd be, anyway, we don't want Mergesort to do anything in that case. And then critical case, because we actually will have to worry about this possibility, what happens if left is equal to right? Okay? Well, in that case, you're asking Mergesort to sort a subarray of length 1, and clearly a subarray of length 1 is already sorted, so there's no work to be done in that case either. All right, so the only real work occurs when left is less than right, and then here goes. This is what it does. It sets middle equal to the average of left and right. Okay? So this, of course, is for the purpose of chopping the subarray from left to right into 2 subarrays. And this could be done in a couple different ways, but here's how we're doing it. The left subarray begins at position left and continues up to position middle. The right subarray begins at position middle plus 1 and continues to position right. Okay? All right, then. The first thing that has to happen after that, after chopping, basically, is to do the 2 recursive calls. So Mergesort is called again to, it was called recursively to sort the subarray from position left to position middle. And then Mergesort is called again to sort from position plus 1 to position right. Okay? When both of those have returned, then we must presume that those 2 subarrays have been correctly sorted. Okay? So now it's time to merge them together. And frankly, there's very little code left to look at, but some of it is quite cryptic, so and may be very strange to you, so try to pay attention here. Okay, the indices I, j, and k are going to be changed here. They're going to, well, let's talk about them. I is going to be used to scan the left half of the left subarray, beginning all the way at the left. And J is going to be used to scan the right subarray beginning at its left. So that's why J was set here equal to middle plus 1, because the leftmost part of the right subarray begins at middle plus 1. Okay, so that's where we want j to begin. All right, I is going to be used to scan the left half, j is going to be used to scan the right half, and k is going to be used as an index into the auxiliary array where we want to copy everything. Okay? All right, now comes this critically important while loop. The while loop has a condition that has two parts. It's the ending together of I is less than or equal to middle and j is less than or equal to right. And that simply assures that I doesn't run beyond the left half and start going into the right half, and j doesn't go beyond the right half, the right subarray. Okay, we don't want either of these indices to run past the half that they're supposed to index into. Okay, so that's okay. Okay, here's the body. The body of the loop is this next indented statement. And if you're not used to the question mark operator, let me explain what's happening here. After the left parenthesis and before the question mark is a conditional statement that says p bracket I less than or equal to, not a statement, there's a condition, p bracket I is less than or equal to p bracket j. Okay? If that's true, then the entry we're looking at in the left half is less than or equal to the entry we're looking at in the right half. Okay. In that case, the code p bracket I plus plus is going to get executed. All right? That basically means that it's going to go grab what's in position I of the array P, and after it grabs that, it's going to increment I. All right? Now I hope you're not getting confused here. I think I could be saying this better. We see the assignment q bracket k plus plus bracket equals. Something is going to be stored in the array q at position k. Okay? What I'm telling you is if p bracket I is less than or equal to p bracket j, then it's going to be p bracket I that gets stored in q bracket k. Otherwise, it's going to be p bracket j that gets copied into q bracket k. In either case, two of the indices are going to be incremented. If p bracket I is what gets copied, then I will be incremented, and so will k be incremented. But if p bracket j is what is copied, then it's going to be the index j that gets incremented along with the index k. All right? So I realize that's kind of cryptic to look at, but the essence of it is you're comparing two entries in the original array, one in the left half, one in the right half. If the one in the left half is smaller, it'll get copied into the auxiliary array, and the index for the left half will be incremented, and the index for the auxiliary array will be incremented. Okay? All right, that process will continue as long as I said before, the indices I and j don't go too far to the right, so that there still are two entries to compare, one in the left half and one in the right half. Okay, but as soon as one of them goes too far, it means you've run out of entries to copy from either the left half or the right half. Okay, think about it. Eventually you're going to either run out of entries to copy into the auxiliary array from the left half or from the right half. Okay? Well, when that happens, that first of the three while loops will terminate. And then it's the job of one of the other two while loops to copy anything that hasn't already been copied from the original array into the auxiliary array. And you could look at that carefully and convince yourself that it works. The upshot is, by the time that's whatever portion of the array is being... the portion of the original array from position left to position right will, at this point, have been copied in a sorted manner into the auxiliary array. And so then it's just a very simple matter of using this very last for loop to copy from the auxiliary array straight back into the original array. Okay? And you end up with that portion of the original array from left to right sorted. Hope that made sense. Look at the code until it does.